Welcome again to our microcontroller lecture. Now we will discuss about also the timer. From the previous lecture, we had discussed about the timer 0, and in this lecture, we will discuss about the timer 1 and timer 2, the second timer and the third timer in PIC16F877. So this is the part 2 of the two parts of the discussion of the timer in the PIC60F877. So let's begin now with a simple explanation or the features of the timer 1. As you know that the timer 1 is 16-bit, not 8-bit, but 16-bit. So they have two registers to hold the value, which is TMR1H and TMR1L right here. Each of this register is 8-bit. So it needs two of each 8-bit register, TMR1H and TMR1L. So just be careful because this is a 16-bit timer counter. It's different from the others two, which is the timer 0 and timer 2 is 8-bit, 8-bit timer or counter. Also in timer 1, this kind of timer also readable and writable, and also software programmable prescaler up to 1 to 8. You can select the internal or external clock just like the timer 0, but be careful that the interrupt or overflow is not from FF to 00, but from FFFF to 0000. Sorry, this is error in the slide. Also, this timer have features of 8 selects for external clock. You can select either 0 to 1 or 1 to 0, or positive edge or negative edge. Okay, that's the features of the timer 1. So, difference from the timer 0 and timer 2, the register for timer 1 is 5. Yeah, 5 registers. The first one is T1 con. This timer is according to the configuration. You can save your configuration in this register, especially for the timer 1 T1 con. The second one is TMR1H and TMR1L. This register as this TMR1H is to store or hold the high 8-bit timer value, and TMR1L store the low 8-bit timer value. Beside of these three register, we have what we have here is PIR1 and PIR1. PIR1 is the timer 1 overflow flag, just like a TMR1EF. PIA1 is timer 1 interrupt enable flag, just like a TMR1 EA. So this 5 registers is only for the timer 1. So you have to read carefully about this function of this register, and you can learn more in the datasheet for the PIC60F877 section of timer. So this is the register according to the T1 con, timer 1 control register. The address is 10 hexa. Just as you can see that you have to enable timer 1 and TMR1 on, or you can stop the timer 1. You can enable or you can stop. And then we have what we have here as TMR1CS. TMR1CS is to select the clock source, just like other timer. You can choose either the internal clock, which is the oscillator is always divided by 4, or external clock. You can connect your external clock to the RC0, the pin of RC0, or T1 0SO, T1 CK. But for simplicity, you can connect the external clock to the RC0. And then what we have here is T1 synchronize. Is the timer 1 external clock input synchronization control bits. When TMR1CS is equal to 1 here, you don't have to synchronize external clock input. But if you you hold the 0 value in this bit, the third bit, TMR1CS, the microcontroller will synchronize external clock input. When the TMR1CS is 0, just like this bit is ignored. And the timer 1 uses the internal clock when TMR1CS is 0. So if you want to the internal clock, you should make the value of the TMR1CS is 1 and the TMR1CS is 0. Sorry. So this can configure to use the internal clock. The fourth bit is T1 OSC enable. So the timer oscillator enable control bit, you have to, if you want to enable the oscillator, you have to store the value of 1 in this bit, the fourth bit. If you store 0, the oscillator is shut off. The oscillator inverter is turned off to eliminate power drain. And the last of two bits, bit 4 and 5, this for to store the value from 1 by 1 and until 1 by 8. Please be careful because the other timer have a prescaler up to 32. But this kind of timer, timer 1, is only up to 8. Divide by 8, I mean. Okay, that's easy and simple to understand. So this is the T1 con, and this is the registers associated with timer 1 as a timer or counter. You can see here that what we have here is TMR1L as TMR1H is according to store the value of the timer itself. And also we've just discussed about the T1 con here, right here. So this 3 is a very important register according to the timer 1. The other is for the interrupt for the timer 1 itself. So what we have here in PIR1, you have to right here. You have to pay attention for the first bit of the PIR1, the TMR1EF, and the other SPA1 is also the first bit of the PA register is TMR1EA. Interrupt enable, this is interrupt flag for the overflow flag. So the other is ENT con. So you have to, I think, you have to enable general interrupt. Okay, general interrupt, this kind of this. So this is the registers 1, 2, 3, 4, 5, 6 according or associated with timer 1 as a timer and counter. So this is the timer 1 block diagram. So just like our discussion before, this is TMR1 and TMR1H and TMR1L is hold the timer value itself. And then you can choose from the TMR1CS the clock source. CS is clock source, either from the internal clock or always divide by 4, or from the RC1 and RC0 pin from external oscillator. So the prescaler is right here. You can configure your prescaler according to the T1 CKPS1 until T1 CKPS0, just like here in the T1 con, the bit 5 and the bit 4. Bit 7 and 6 is implemented right as 0. So this is then the clock is connected to the synchronize. If you want to synchronize right here, synchronize clock input or using synchronize other input. Okay, this is our explanation about the register and timer. So the timer 1 calculation example is according to our previous slides. For example, if we want to calculate one delay 100 millisecond with frequency of the PIC is 20 megahertz and the prescale is 8, so we can use our equation from previous lecture or previous slide. That is the timer max is 65,536 minus delay multiplied by f oscillator and divided by prescaler multiplied by 4. So what we have here is 3036 or 0BDC in hexadecimal format. So this kind of calculation you can use your software just like our previous lecture to calculate the timer 1 delay. So this is the 7 steps of the timer 1 programming. First, always calculate the timer count, just like this calculation, or you can use the software. And then set the prescaler bit as a T1 count as per the delay calculation. This one, register value, the timer for the delay 100 millisecond. Select the clock source internal using TMR1CS. Load the timer value to TMR-H and TMR1. Okay, the prescaler is according to the 8 here, and the timer value is according to the 0BDC. So this is 16-bit. And then enable the timer interrupt using the TMRIEA bit. And then enable the global peripheral interrupt using the ENT con right here, bit 7 and bit 6. And then finally start the timer by setting TMR1 on. So you can set on or set off using this bit. Okay. So this is the bare metal programming, but don't worry because we can use the constanta according to our register to setting up the timer. So this is the example. What we have here is at first you have to define the first as bit PS1 is 5, the other is defined as bit PS0 is 4. So in the main program, you need to maybe it's not significant, but we have an example of the playing in the port G, so you have to make it 0 interest D according to the output of for the port G. So the T1 con is enabled for the 5th bit and 4th bit, timer 0 with external frequency and 8 as prescaler. So this one is S bit PS1 and S bit PS0. This is the value that we have calculated before, just like this. So this is for the high, and the other is for the low. Okay, just a minute. So this is for TMR1H, and the others is for the TMR1L, and the prescaler is 8. So according to this kind of register, sorry, yeah, is 8. So what we have here 1 1. So you have to write here 1 and 1. So the prescaler value will be 8. Okay, 1 and 1. The 5 bit and 4 bit. So the right here. Okay, this is the 5th bit and this is the 4th bit. Is we can assign the value of 1, the logic 1. So this kind TMR1H and TMR1L can be write like this. Okay. So in the interrupt enable, you have to set the bit to 1. Okay. Also the global and also the peripheral. And then you can start the timer using TMR1 on equal to 1. So this is the infinite loop. Infinite loop. Okay. If they achieve the overflow, they will execute this interrupt. if overflow, that's if overflow, then something like that. The value is complement of the previous value, and then you have to save 0BDC like before manually, and also clear the timer interrupt manually. So you have to load the timer manually and clear the time interrupt manually. Just to remember, okay? Be careful for that kind of value. So this is the same with 100 millisecond for the blink, but using the timer one. So we can connect the pin to the oscillator. So this is the results using the 100 millisecond row. So this one 100 millis delay. Okay, 100. This and every box here is 100. So this is 100 millisecond delay, up and down, and for the toggle blink on off. So if you have to use the timer one for 10 milliseconds, 8-bit 10 milliseconds for timer one, you can accurately have a configuration. So this is initial for timer one, the T1 con is 0, the timer F bit is 0, timer 1 H is P1 E0. Okay, this is the interrupt. So you can enter your code here, but be careful for the value right here, because it's according to the hour delay 10 millisecond for timer one. You can try what about the 100 millisecond using frequency of 20. Okay, 20, yeah, 20 megahertz, something like that. But this case for the software, we use 8 megahertz. So next is timer 2, the last one. After timer 0 from the previous lecture, and then timer 1 in this lecture, and also the timer 2. The timer 2 is like the timer 1, timer 0, sorry, which is 8-bit timer counter. You can read and write to this counter, and also software programmable prescaler or postscaler up to 1 to 16, and the overflow will be from FF to 00 because it's only 8-bit. So from FF to 00, not FFFF, but FF to 00, just like timer 0. So just like our timer 0, like here, we have only 4 registers. The first one is to control register for the timer 2. Just be careful because timer 2 is also to generate the PWM. So if you want to generate the PWM, we will discuss about it in the next lecture. You cannot use the timer 2 because it's already used for the PWM generators. So back again to the timer 2 registers. The first one is the register for the configuration of the timer 2, and the other is the MR2 is according to the register that hold the timer value, just like timer 0 and timer 1. And the other is PIR1 and PIA1 is according to the overflow and enable flag for the interrupt in timer 2. Okay, so that's an easy way to understand the register. Just take a look at this table register, this description. So what we have here is the T2 count according to the configuration. The first 2 bits here is according to prescaler is only different from the timer 0, and the prescaler is only for 1, 4, and 16. Yeah, not up to 32. That's for the timer 0, but in timer 2 is only prescaler to up to 16. So you can start and stop the timer using the TMR2 con, TMR2 con, bit 2, and the other is output postcal. You can configure the prescaler up to 16, but you can also configure the postscale up to 16. Okay, from 1, 2, 3, 4, 5 until to 16 postscale. That's the difference between timer 0 and timer 2, because timer 0 and timer 1 doesn't have a postscale, but only timer 2 have a prescale and also postscale. So this is the register associated with the timer 2 as a timer counter. This is intercom PR1, PIE1. This one is for the TMR2 register. The other is just I mentioned before, TMR2 to hold the value, T2 con for the configuration, and PR2 for the timer 2 period register. So TMR2 is according to the PR2. PR2 is according to the period register, but the TMR2 is according to the timer value itself, timer 2 value itself. So this is the timer 2 block diagram from the oscillator clock. You can I think you cannot select the source of the clock. Okay, for the timer 2 only the internal and divide by 4. So this one is using the prescale. This is timer 2 register. Comparator PR2 register is according to the PWM generator. So you can send the flag, but you can also configure the postscale. Okay, the postscale if comparator, using this comparator postscale 1 to 1 to 1 to 16. Okay, in the TMR2 register itself, you can if this kind converter, you can reset the TMR2 register itself. So what we have here is example of the timer 2 calculation example. What about the generating 1 second? 1 second. Okay, 1 second delay, not 1 millisecond, not 10 millisecond, not 100, but 1000 millisecond or 1 second delay using timer 2. Okay, as the timer 2 is 8-bit and support 116 prescaler, it's not possible to directly generate the delay of 1 second, because the maximum delay with 116 prescaler will be delay. You can use this kind of equation, just like I have mentioned at the last lecture. Is delay is maximum is 819 microsecond, not millisecond. So this is the maximum delay if you use the 16 prescaler. Now, but we can make it to 500 microseconds. So we can make the timer delay 500 microsecond, and we can repeatedly 2000 times. Okay, 2000 times to get the 1 second. So we have to make 2000 times of each of 500 microsecond to get 1 second. So 2000 multiplied by 500, okay, is about 1000, 1 million microsecond. So the delay calculation for 5 microsecond at 20 megahertz with prescaler of 16 is right here. So you have to store the 100 value in your TMR2. So this is the 6th step of the timer 2 programming. The first, you should calculate the timer count from the required delay. The second step is to set the prescaler bits and T2 con as inverter delay calculation. Load the timer value into the TMR2 using for the example is you should store the 100 here like this to TMR2. Enable the timer interrupt and also enable global and peripheral. So you can start the timer using setting up the TMR2 to on. So this is the from the main T2 con is always timer 2 with external flux 16 as prescaler, and then TMR2 is 100, TMR2 EA is 1, and also like the previous program, and this is the TMR2 is equal to 101 because timer is 100 instead of 100, as the timer 2 needs 2 instruction cycle to start incrementing one TMR2. TMR2 EF is equal to 0. If count 2 is equal or more than 2000, then you have to reset the count and you set the value. Other, you can increment the count. So if So every interrupt, you can increment the count until 2000 loop. 2000s repeating the 500 microsecond. So because the 500 microsecond multiplied by 2000 is 1 million microsecond is equal to 1 second. Okay, so this is the output from the digital oscilloscope. This is 1 second delay. Okay, this box, every box is 1 second. So this is exactly 1 second delay. You can use the 10 milliseconds, but not accurately for this kind of the Timer2 calculator using 8 megahertz frequency. You can change 8 to 16 maybe, or to 20 megahertz, and see the result if accurate or not. So this one is the best of our software here. You can use the C language, basic language, or Pascal language. Okay, so that's for our discussion about the Timer1 and Timer2, and that's all for the discussion of the timer, because PIC16F877 have only 3 timers: Timer1, Timer2, and Timer3. Sorry, Timer0, Timer1, and Timer2. Three kind of timer. Just remember that only Timer1 is 16-bit timer or counter. The others two, Timer0 and Timer2, is only 8-bit timer counter. So that's the difference. And the difference between Timer0 and Timer2 is according that Timer2 have a pre-scale and post-scale, but not the other two. Timer1 and Timer0 doesn't have a post-scale, just only pre-scale. So according to this features of the pre-scale, post-scale, the frequency, you can select the internal or external oscillator, except the Timer2. In the Timer2, you cannot select the internal or external clock, just only for the internal clock, which is the internal clock always divide by 4. Just remember that. So you can make many combination according to this timer, using the pre-scale, using the select of the internal oscillator. But using this pre-scale and choose the frequency chosen according to the clock, you can make many combination according to your requirements, especially for the delay time, because we use this timer for the advantage of the accurately delay time. Okay, or you can measure the time. If you don't want to accurately, just only maybe you can, if you want to make a 5 milliseconds, it's not significance for the accuracy, you can use the for loop, something like that. But if you want to accurately delay 500 milliseconds, for example, you have to use the timer. You can use the Timer0, you can use the Timer1, and maybe you can use Timer2. Okay, if you have any questions about these lectures and the other lectures in our YouTube channels, you can comment below, that I will be answers, yeah, as soon as possible, or as I get access to the YouTube and read your comment and something like that. Okay, thank you very much for your attention according to our timer lectures. Next, we will discuss about the PWM generation in our microcontroller PIC16F877. Thank you very much, and we'll see you to the next lecture. Bye.